When installing arc fault circuit interrupters, or AFCIs, in areas where they are required, the question of using a 3-wire circuit versus a dedicated neutral often arises. While a 3-wire circuit can be used in conjunction with an AFCI, it is crucial to understand the importance of providing a separate neutral wire for each AFCI protected circuit. The functionality of an AFCI relies heavily on the integrity of the neutral wire to effectively monitor current flow and detect potential arc faults. If the neutral wire is shared between multiple circuits, the AFCI's ability to accurately detect arc faults on the intended protected circuit can be significantly compromised. This is because the AFCI measures the current flowing through the hot or phase conductor and compares it to the current returning through the neutral conductor. Under normal operating conditions, these currents should be equal or very close to equal. However, if an arc fault occurs, it creates an unintended path for current flow, leading to an imbalance between the hot and neutral currents. The AFCI is designed to detect this imbalance and quickly trip the circuit, interrupting the current flow and mitigating the risk of fire. When a neutral wire is shed, the current from other circuits can introduce noise and interference into the AFCI's measurements. This can make it difficult for the AFCI to distinguish between a legitimate arc fault and normal fluctuations in current. In some cases, the AFCI may fail to detect an arc fault altogether, leaving the circuit unprotected. In other cases, the AFCI may nuisance trip, interrupting the circuit unnecessarily. To ensure proper operation and reliable protection against arc faults, it is strongly recommended to use a dedicated neutral wire for each AFCI protected circuit. This means that each circuit should have its own individual neutral wire that runs back to the neutral busbar in the electrical panel without being shared with any other circuits. By providing a dedicated neutral, you eliminate the potential for interference from other circuits and allow the AFCI to accurately monitor the current flow on the protected circuit. This will help to ensure that the AFCI can effectively detect arc faults and trip the circuit when necessary, providing a high level of safety for your home or building. The National Electrical Code, (NEC), provides specific requirements for the installation of AFCIs, including guidelines for the use of dedicated neutral wires. It is important to consult the latest edition of the NEC and any applicable local codes to ensure that your electrical installation complies with all relevant regulations. Article 210.12 of the NEC covers arc fault circuit interrupter protection. This section requires AFCIs to protect branch circuits that supply certain locations in a dwelling unit, such as bedrooms, living rooms, dining rooms, family rooms, recreation rooms, and closets. The specific requirements for AFCI protection may vary depending on the addition of the NEC and any local amendments. However, the general principle of providing adequate protection against arc faults remains the same. In addition to using a dedicated neutral wire, there are other factors that can affect the performance of AFCIs. These include the quality of the wiring, the type of loads connected to the circuit, and the presence of any electrical noise or interference. It is important to use high-quality wiring materials and to ensure that all connections are properly made. Loose or corroded connections can create resistance, which can generate heat and potentially lead to arc faults. When selecting electrical loads for an AFCI-protected circuit, it is important to consider the potential for harmonic currents. Harmonic currents are non-sinusoidal currents that can be generated by certain types of electronic devices such as computers, televisions, and LED lighting. These harmonic currents can interfere with the AFCI's ability to accurately detect arc faults, potentially leading to nuisance tripping. To mitigate the risk of nuisance tripping caused by harmonic currents, it is recommended to use electrical loads that are designed to minimize harmonic distortion. This may involve using power conditioners or filters to reduce the amount of harmonic current generated by the load. Electrical noise and interference can also affect the performance of AFCIs. Electrical noise can be generated by a variety of sources such as radio transmitters, motors, and electronic devices. This noise can interfere with the AFCI's ability to accurately monitor the current flow on the circuit, potentially leading to nuisance tripping. To minimize the impact of electrical noise, it is important to ground all electrical equipment properly and to use shielded wiring where necessary. Shielded wiring can help to block out electrical noise and prevent it from interfering with the AFCI's operation. In addition to the NEC requirements and best practices for AFCI installation, it is important to understand the different types of AFCIs available. There are two main types of AFCIs: branch/feeder AFCIs and outlet branch circuit AFCIs, or OPC AFCIs. Branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit, including the wiring and any devices connected to the circuit. OEC AFCIs are installed at the first outlet on the branch circuit and protect the wiring downstream of the outlet. OEC AFCIs are typically used in retrofit applications where it is not possible to install a branch/feeder AFCI in the electrical panel. When selecting an AFCI, it is important to choose a model that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. This will ensure that the AFCI has been tested and certified to meet the applicable safety standards. It is also important to choose an AFCI that is compatible with the type of wiring and the electrical loads in the circuit. Some AFCIs are designed for use with specific types of wiring, such as copper or aluminum. Others are designed for use with specific types of loads, such as lighting or appliances. Before installing an AFCI, it is important to test the circuit to ensure that it is properly wired and free of any existing faults. This can be done using a multimeter or a circuit tester. If any faults are detected, they should be corrected before installing the AFCI. Once the AFCI is installed, it is important to test it periodically to ensure that it is functioning properly. This can be done by pressing the test button on the AFCI. When the test button is pressed, the AFCI should trip, interrupting the circuit. If the AFCI does not trip when the test button is pressed, it may be defective and should be replaced. In summary, when installing AFCIs, the following points should be considered. Firstly, a dedicated neutral wire for each AFCI protected circuit is crucial. Secondly, consult the latest edition of the NEC and any applicable local codes to ensure compliance. Thirdly, use high-quality wiring materials and ensure proper connections. Fourthly, consider the potential for harmonic currents from electronic devices. Fifthly, minimize electrical noise and interference by grounding equipment and using shielded wiring. Sixthly, choose an AFCI that is listed and labeled by a recognized testing laboratory. Seventhly, select an AFCI that is compatible with the type of wiring and electrical loads in the circuit. Eighthly, test the circuit before installing the AFCI to ensure it is properly wired and free of faults. Ninthly, test the AFCI periodically to ensure it is functioning correctly. By following these guidelines, you can ensure that your AFCI installation provides reliable protection against arc faults and helps to prevent electrical fires. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician can ensure that your electrical installation is safe and compliant with all applicable codes and regulations. This information is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Proper selection, installation, and maintenance of arc fault circuit interrupters are essential for ensuring electrical safety and preventing fires in residential and commercial buildings.